Hello KITT, how are you doing?
I am functioning optimally, Michael, and awaiting your instructions.
Hey, my name is Stephan from ai-coustics, and I want to show you today how you can build your own local voice agent and improve it with the ai-coustics speech enhancement and voice activity detection. So here in the code, you see the project is called Knight Rider because we use the British Knight Rider voice and then prompt it to behave a bit like KITT. A normal voice agent is made out of multiple components, right? So you have a large language model, speech-to-text module, and a text-to-speech module, which then generates the actual voice of our agent. A significant part of this model is the VAD, or voice activity detection. This will select when actually the user, or me in this case, is speaking and when a sentence ended. And then the speech-to-text model tries to generate a transcript out of it. Here we are using Whisper for this from OpenAI, which is one of the most used speech-to-text models. And for the VAD, we are now using our own ai-coustics VAD. But not only is it doing that, this VAD processor here will also call our Quail real-time models to enhance the audio signal of the voice. So it will remove the background noise slightly and make the voice a bit more present, so it is easier for Whisper to transcribe the speech into the correct text. Let's have a look how it works. We open an audio device because we need to get the microphone input and send the audio back to the speaker. This is how we can generate speech. So just text-to-speech create and what you want to say. And this will return an audio data that you can send to the audio device. And here's the main program loop, which will always run limitless. And in there, we will check our audio device if enough samples were recorded already, so we can call our VAD. Yeah? VAD has typically a window size or block size that it has to operate on. As soon as we have those, we can collect, we can receive this audio from our audio device and have here a vector of audio data, that's our speech input segment, and then call the VAD processor with it. In this case, the process function will then enhance the speech input and collect it into a longer vector. So this will run in a loop until the complete sentence has finished. And when a complete sentence has finished, so the voice activity detection went to true and then back to false, we will receive the speech segment here. So this is the complete audio data for basically one sentence. We set the audio device receiver to false because now we don't want to have a feedback loop, so the voice agent will prompt itself again. And then we can transcribe our speech segment, which is already enhanced by our ai-coustics processing, and transcribe it to this text transcript. And if this transcript is actually contains actual data, we can send this transcript to our LLM. Yeah, here's the LLM.chat function. And this will now block the function until we get our response of the voice agent. And this response is still text that we can then here transform to the generated speech that we send back to the audio device. Let's have a listen how that works. So for the LLM, we use Llama server because it's really fast and we can run it locally. And we use the Gemma 3 1 billion model. That is downloaded automatically when you call this function. Let's try to start the server. Model loaded, server is listening. And now we can run our program here.
All systems ready.
Hello KITT, how are you doing?
I am functioning optimally, Michael, and awaiting your instructions.
What could we do today?
Observe, Michael, and I shall analyze your schedule to determine optimal efficiency.
Okay, and this is the agent. You see how fast it works, that the transcript was always correct. Okay, that's also now not the noisiest environment, but you will see that the results are generally better. Feel free to play around with this project. It's on GitHub, ai-coustics Knight Rider, and yeah, have fun.